Hey everyone, it's a great pleasure to be here in front of you and here in this great town of Prague. Today I'm going to talk about tokens that are doing a spacewalk. I'm going to talk about tokens that are doing a spacewalk from one blockchain to another blockchain. Well, actually I'm talking about bridges. Spacewalk is a unified bridge concept for Polkadot, which is decentralized, trust minimized, and censorship resistant. These are three aspects that are very important to us when it comes to bridges. Unfortunately, not every bridge exhibits those aspects, and they are prone to attacks. And as you know, a lot of attacks happened in the last couple of months and weeks on bridges, and Spacewalk is supposed to change that. Hello, I'm Torsten. I'm the CTO of Pendulum. Pendulum is the project behind Spacewalk. Pendulum is also one of the sponsors here. But before I'm going to talk about Spacewalk, for that reason, I want to talk about Pendulum and present Pendulum to you. So Pendulum is itself a parachain project on Polkadot. We're not live yet. So Polkadot is, of course, we are not on Polkadot now. We will be on Polkadot later this year. That's what we intend. But we're currently preparing our launch on Kusama. In addition to this, our testnet is live. We're also part of the Substrate Builders program in the chains track. And this project is heavily in development. Spacewalk itself has the mission to connect fiat networks with the DeFi ecosystem. What that means is that our goal is to become the central hub for stablecoins on Polkadot. Let me be more specific. Spacewalk is tailored for Forex, for the Forex market. Pendulum is tailored for Forex, and Pendulum intends to be the ideal ecosystem for debt developers when it comes to Forex. And when I say Forex, I of course mean foreign exchange. Additionally, Pendulum is tailored for business. That means that if you're a business with business needs, for example, compliance, then Pendulum will also be the ideal project to build your application on. One example could be the cross-border payments from business to business, B2B. Another USP of Pendulum is that we integrate with local banks. And what that means is what I'm going to show on this next slide in this example. So here you see Pendulum in the middle, and the local banking integration means that Pendulum will have local integrations, on-ramps and off-ramps with fintechs and banks in different regions. For example, if you want to make a fiat transfer, a cross-border transfer from region A to region B, we would then use those local fintechs and banks to tokenize the fiat currency in region A and detokenize the fiat currency in region B. And in between, we have Pendulum to actually exchange those stable coins, those fiat-backed stable coins from region A into region B. And that happens through, for example, a Forex AMM, or actually a whole network and system and ecosystem of Forex AMMs. A Forex AMM is an automated market maker optimized for Forex, for foreign exchange. And that means, this optimization means that, for example, it has curves that are optimized for Forex or one-sided liquidity pools. I'm going to talk about this in more detail later. Now, if you have this cross-border transfer, you tokenize the asset in region B and then use the Forex AMM to exchange it, and then at the end you detokenize in region B, and that's how it will happen with Pendulum. Clearly, those local banking integrations are important for Pendulum, but I said that we intend to become the central hub for stablecoins on Polkadot, and we only achieve that if we also build bridges to all the other great blockchain ecosystems out there that have a big support and great support for stablecoins. For example, Celo, Stellar, Solana. And since we are going to build those bridges, or actually already building those bridges, we looked at many different bridge concepts. And we looked at those blockchains, how to build bridges to them. Turns out, it's very diverse and it's very complex. There are many different approaches to bridges, and you need many different approaches because those blockchains have different needs and they work differently. And so it became clear to us that we need a unified approach to this bridge building, and that's where Spacewalk comes in. Now, in addition to this, with those bridges that we build to those other blockchains, we bring in those stablecoins from the other project into the Polkadot ecosystem and make them, of course, available not just to Pendulum, but also to the other projects on Polkadot due to the power of XCM and so on. Now let me talk about Spacewalk itself. So Spacewalk is a standardized bridge concept for .sama. To be more technical, it's actually a bridge concept for substrate chains. And it's not just a concept, but it's also a concrete implementation. And it's an implementation that's actually independent of Pendulum. I said that we are going to use it in Pendulum, but it's an independent project. It's its own repository in GitHub, has no reference to Pendulum, and you're free to integrate it in your own substrate chain. What that means is that it boils down to a pallet, a substrate chain component that you can plug into your own chain, and by that you can actually employ the power of Spacewalk for your own project. It's not just a pallet, but it's actually also a set of clients, depending on what kind of blockchain you want to connect to. Those clients could be oracles, price feed oracles that you need to run, or custodian clients, and so on. As you see here, Spacewalk itself has been rewarded with a Web3 grant. That's the new announcement I want to make today. It's just very recent. And before we continue to look into some more details, I want to talk again about the features of Spacewalk. Namely that Spacewalk is first decentralized, and that's very important. When you look at many different bridges out there, you realize that unfortunately a lot of them just claim to be decentralized, but are not really 100% so. And some of them are even totally centralized from the beginning. And of course that's a very big attack vector, as we have realized in the last couple of months. Additionally, Spacewalk is trust minimized. What that means is that it could be that you have to interact with a human actor, for example, a human custodian. But those clients, those human clients, will always be economically incentivized not to misbehave. And even if they misbehave, you will be guaranteed to get your money back at the end, so that you don't have a problem with those human actors. Finally, Spacewalk is censorship resistant. Again, that means that if you have to interact with a human actor, that human actor could be free to deny service to you, but you always have the chance to go to another human actor in that decentralized network, or to even join the network yourself at every point in time and can become one of those clients yourself. By that, Spacewalk always guarantees service to you. Now, let me look at how Spacewalk integrates in your blockchain. I said that Spacewalk is a unified approach. It has unified components and a unified API for you to build bridges to other blockchains. What that means is that the palette comes with components for different blockchains like Stellar and Solana and so on that reflect the logic of that blockchain, but the whole API that connects to your own chain is unified. And let me give you an example of what that unification looks like. So let me talk about unified mappings here in this example. When I talk about mappings, I mean mappings from certain aspects of one blockchain to according aspects on another blockchain. One example of those aspects could be how to represent assets. Assets are represented very differently in different blockchains. On Bitcoin you have BTC, on Ethereum you have ERC20 tokens, smart contracts. On Substrate you would most likely not use smart contracts to represent your assets, but you would use a palette, like a multi-asset palette or multi-currency palette. So you see that assets are definitely represented very differently, and if you want to build bridges to different blockchains, you have to reflect that. Spacewalk is going to unify this. Another aspect that we need to consider is how amounts are represented. Amounts can be represented in different kind of number formats, bit widths, and so on, or a unit could look different in one blockchain in regards to another blockchain. For example, a unit is 1 trillion units or 1 billion units on another blockchain, and also that needs to be unified through Spacewalk. A third unification aspect would be to unify addresses. Blockchains have different address spaces. For example, Ethereum has Ethereum-like addresses. On Substrate, you have a different address format, although you're more flexible, but usually you have. If you, for example, want to connect to Bitcoin, you can go the Moonbeam route and integrate or use unified addresses where you have only Ethereum-like addresses in your whole system. But if you want to connect to more than one blockchain, you already run into the problem that then you definitely need to deal with different address spaces. And Spacewalk is also going to unify that. Finally, if we talk about different address spaces, we also have to talk about different signature schemes. As you know, addresses usually derive from public keys, and if you have different signature schemes, then you also have different public key formats, and also that needs to be unified if you sign transactions differently between blockchains, and also that is achieved through Spacewalk. Now that's a lot of theory, and I want that we have a little bit of fun and look into a concrete example. And here I want to pick the example of the Stellar instance of Spacewalk. And I do this for a particular reason. Namely, we as Pendulum are very interested in stablecoins, that's what I said, and Stellar is very good at that. What I mean is that there is a different field, or that there is a big variety of different kinds of stablecoins. And just recently we saw that the algorithmic stablecoin variety is maybe not the best one. You saw the crash of Terra and also other projects. And Stellar particularly focused on fiat-backed stablecoins, and is really good at that. They have local banking integrations in many different countries, and allow to tokenize, for example, Brazilian reais or Nigerian nairas. And in total, they have more than 15 stablecoins, fiat-backed stablecoins, and that's really a great achievement and very important for Pendulum. Now, there's also another reason why I want to talk about Stellar. Stellar is very challenging, or building a bridge to Stellar is very challenging, and that's why I want to present that today here, because we like challenges, and we want to see how Spacewalk can cope with that. Why is it challenging to build a bridge to Stellar? Well, that boils down to a couple of factors. One of them would be that Stellar does not allow for smart contracts. It's a big advantage if you have smart contracts in your target chain, because you can encode the logic of the bridge as a smart contract, and smart contracts don't require trust. You can study how the smart contract works, you can see that it works reliable and according to the protocol, and then you can really rely on the bridge usually. If you don't have smart contracts, you need to replace them with human actors that control accounts on the target chain. And human actors usually require trust, and you have to deal with this somehow. There are two more factors that are important and that are missing in Stellar, and this is that Stellar does not allow you to build a classical chain relay. A chain relay is a typical component of a bridge. For example, if you build a bridge to Bitcoin, you would have a chain relay. And a chain relay is based on two different aspects that you have in proof-of-work blockchains. For one, a proof-of-work blockchain would use Nakamoto consensus usually, and what that means is if you look at all the blocks on the blockchain, or actually just looking at all the headers of the blockchain, and you arrange those headers sequentially, you will see that the blockchain is not just one sequence, but it actually branches out. But if you just look at the headers and the weights that are encoded in the headers, you can always identify what's the currently valid subchain. So the headers give you all the information about what blocks are currently valid. You still don't know what's inside the block if you just have the headers, and chain relays usually only deal with the headers, but everyone can come to the chain relay and prove that a certain transaction is inside that block, and that works reliably. That's based on the fact, on something called the Merkle proof. You're probably familiar with this, but if you're not, a Merkle proof is based on the fact that transactions inside a block, at least on most blockchains, are arranged in a tree, a Merkle tree. And if you want to prove that a certain transaction is inside that tree, you just need to give information about the path from that transaction that's somewhere down there in the tree up to the top of the tree, and this path is usually very small. Actually logarithmically small. If you have a block with, let's say, 1,000 transactions, then this path would only consist of 10 nodes, so much smaller than the actual block. That means that those Merkle proofs allow you to do very efficient proofs, or you can very efficiently prove to the chain relay that a certain transaction is inside the block. And this efficiency is important for bridges, because efficiency means scalability, and of course you want to have bridges that allow for a lot of transactions per second. Now, unfortunately, Stellar does not have Nakamoto consensus, and it doesn't have Merkle trees, or it doesn't arrange their transactions in Merkle trees, but just plain lists. And for that reason, you don't have efficient inclusion proofs. So none of those things exist on Stellar, and we needed to find a workaround for that. Before I talk about that workaround, I first want to talk about the basic operation of the bridge. This bridge allows for two very basic operations, namely you can move a token from Stellar to your substrate chain and back again. And here I'm going to use the terminology of inter-BTC. You listened to the talk of inter-BTC today, so you will be familiar with what I'm talking about here. And I will also tell you why I use the terminology of inter-BTC. I think I just realized that I need to hold the mic like this, and it's easier to understand me. So one operation of moving a token from Stellar to the substrate chain is called the issue operation. And this just happens by moving the token in Stellar to a specific account, which is called the locking account. And you would lock that token in there and make it unusable on Stellar side. At the same time, you would use your Spacewalk pallet in the substrate chain, and that Spacewalk pallet has the power to mint a token and send it to your target account in the substrate chain. And this token is then actually a wrap token, which is backed by the lock token in the locking account. Now, the other operation is called the redeem operation. That's when you want to move back that token from substrate chain to Stellar. And it's very easy. You just use the Spacewalk pallet again to burn that token that you initially created. So you burn the wrap token. And at the same time, you just unlock the token from the Stellar account and send it back to the user. This scheme is very simple and actually works quite well. The main problem, though, is that the locking account is not controlled by a smart contract because, as I said, Stellar doesn't have a smart contract, but it needs to be controlled by human actors. And for that reason, we have a problem because those human actors need to be trusted. They could actually just run away with the money that you locked in there. And one way to actually remedy this problem is that you decentralized those human actors and use something we call a decentralized authority. That's a very basic approach that I show here. So what you do is that you don't have just one person that controls the account, but you have something like a committee controlling this account, multiple signers. That's actually very easy to implement in Stellar because Stellar has a built-in multi-signature features, a feature where you can have multiple people that control one account and they always have to sign transactions for that account together. Actually have something like an N out of M multi-signature scheme where a certain subset of the account holders, they need to agree in order to sign a transaction. This approach is not really decentralized, though, because it has its limitations. And one limitation is that in Stellar, you can only have 20 co-signers for one account. It's a limitation that's built into Stellar. And if you have such a limitation, I think it's fair to say it's not really decentralized, because once you reach those 20 signers and 20 people join that network, you cannot join it anymore. And if you are not able to join that network, I mean, it's definitely not censorship resistant and not decentralized. And another problem with this approach is also that it's quite complicated to coordinate everything. The signing and the change of signers requires actually its own protocol to transmit that information between the signers. They need to somehow coordinate how they sign everything. And it makes everything quite complex. The biggest problem, though, is that this scheme is subject to Sybil attacks, where one malicious actor could take over a certain number of signers and let them work on behalf of the malicious actor. And that's actually invisible to the outside world. And that actually happened with one big bridge just a few weeks ago at the end of March. This bridge had a 5 out of 9 co-signer committee. So 5 people were required to co-sign or act on behalf of that locking account. And one single malicious actor was able to take over 5 of those signers and could run away with $600 million. That's a big shame. And definitely a problem which is due to this limitation. So what's the solution? Our solution is actually based on inter-BTC, which is really a great solution for these kind of problems if you want to connect to a blockchain that doesn't have smart contracts. And if you listen to the inter-BTC talk then by Caroline, then you will also see that there are a lot of similarities with the Spacewalk approach for Stellar. But let me go through the details again here, or to some of the details. First off, in order to have a truly decentralized system, we need to introduce vaults. So those vaults are actually a replacement of that one locking account. And what's also important is that everyone at every time can become their own vault and just join that network of vaults. It's a truly permissionless, decentralized network. And it's also a very dynamic set. Everyone can at every point in time become their own vault or leave that network again. So what we achieve is not decentralization by co-signers of one account, but decentralization by having just a multitude of locking accounts or vaults. Now we still have human actors, and we still need to make sure that they don't misbehave. And that is achieved through collateralization. Every vault first needs to lock collateral with the Spacewalk palette. And what you usually have is that what you require is that this is actually over-collateralized. That means that the collateral that those vaults need to lock needs to have a higher value of what can be in the locking accounts or in the vaults. And let's look at an example. Usually the assets that you would use for the collateral and for the locking account are different. For example, you would use, in Polkadot, you would, for example, use DOT, the native Polkadot token, for the collateral. And you would, for example, have USDC in your locking accounts because someone wanted to use the bridge for USDC. And since these two different assets can always change in value, it could easily happen that one point in time the collateral is not worth as much as the locking accounts anymore because, for example, the DOT value fell so much that it fell below this, the value of the vaults. And what happens then is that the Spacewalk palette is observing this, and at one point in time, if the value of the collateral drops too much, it will then liquidate the vault. Liquidation sounds pretty harsh, but it basically just opens up the vault for arbitrageurs, and those arbitrageurs at the end will make it possible for the people that locked their tokens in the vaults to get all their tokens back. Now the final component is the Stellar Oracle, and that's actually maybe the biggest part where Spacewalk for Stellar differs from InterBTC. The Stellar Oracle is the component that solves the problem that I initially presented, namely that building a bridge to Stellar is quite complicated. This Stellar Oracle is responsible for conveying information about Stellar to the substrate chain, or more precisely to the Spacewalk palette. The Spacewalk palette needs information about what happens on Stellar in two instances. First, whenever someone makes an issue, that means moves token from Stellar to the substrate chain, the Spacewalk palette needs to know about this because the Spacewalk palette then, in the next step, needs to mint tokens and send it to the user inside the substrate chain. The other instance where the Spacewalk palette needs to know about what happens in Stellar is when a vault operator misbehaves and tries to run away with the tokens. Because then the Spacewalk palette would come in and actually slash the collateral and liquidate the vault. So now let me talk about how that Stellar Oracle looks like. And I cannot go into all details because it's quite technical, but I just want to give a quick glance of this. The Stellar Oracle is very much based on how consensus works in Stellar because it's a very different system. It's its own Stellar consensus mechanism called the Stellar Consensus Protocol. And it's very unique. Something that's different about Stellar is that you have, on one hand, a decentralized network, but on the other hand, it's not necessarily a network where every node is created equal. Every node in a network expresses what other nodes it trusts. And if you look through the graph of trust, you see similar to, let's say, PageRank in the internet, you see that some nodes enjoy more trust than other nodes. If you take all the nodes together that have the highest trust in the network and you group them, then this group is actually called the group of Tier 1 validators. There are currently about 25 Tier 1 validator nodes that have the highest trust in the whole network. And whenever a block in Stellar gets finalized, all the nodes vote on that block. And if you look at the structure of the Tier 1 validators, you will see that this voting mechanism is almost like a delegated vote. That means that all the other nodes trust on what the Tier 1 validator nodes vote on. So it's totally enough or totally sufficient to just observe what the Tier 1 validators do when they vote on finalizing a block. And that information is enough to know what happens in the Stellar network and what blocks are valid. Now, what's also important to know is that whenever a tier 1 validator node votes on something, they will send out a message, and that message is signed. Now, we know the public keys of every tier 1 validator, and we can easily encode this in the Spacewalk palette because it's not a lot of nodes. And using those public keys and the knowledge about the structure of the tier 1 validator network, it is totally possible to reliably know what happens inside the Stellar network by using the Stellar oracle that transmits the signed messages. Now, what's also important to know is that this structure and the public keys of the tier 1 validator network rarely change. It only happens like once a year or so. And we can easily encode that information in the Spacewalk palette and update it through governance whenever any structure or anything in the tier 1 validator network changes. So by this, we can guarantee that the Stellar oracle is at least as reliable as the Stellar network itself. That's all I want to present about the Stellar instance. Finally, I want to show some links to you. Some link to our Pendulum project, the link tree, also to our Twitter account, and finally to our GitHub account, and I ask you to also get involved. Spacewalk itself is not just for Pendulum, but for all. It's a community project, so we're happy for every contribution. Get involved, and finally, I want to also show some links to my accounts. Connect with me. Very happy to talk to everyone here. That's it for my presentation. Thanks a lot. And if you have any questions,